here. We're solving exponential equations, and we start out with a common base. These are so easy that the first problem we do, I think you probably have a first grader at home that might be able to do it. Maybe. Yeah, I know. I almost pulled it out, didn't I? All right.
I guess we could skip to that.
Yeah. We just reviewed. We spent a half hour or so reviewing, which I think was important. But the best practice is just doing them yourself. Just keep doing some. Find some more on the internet. Go to YouTube.
Those are for homework.
Yeah, those are your homework. I'm not going to make you do homework from these right now. I'm going to let this stew in your brain. All right, there's a little saying that we have in the math world that when we're solving exponential equations, here it is. If the bases are the same, then the exponents have to be the same. Because this is 3 to something equals 3 to something. That must mean the two somethings must be equal to each other. They must be the same. So when we have an equation of two exponential functions with the same base, that means the exponents have to be the same.
Hey, it makes sense.
So I write.
Both the things are equal to each other.
That's right. So here's my simple equation to solve for x. Some of you already have the answer right now. Yep. What is the answer?
8.
Okay. I don't know if he's right. Plus 9 to x equals to 16 divided by 2, x equals to 8. And if you want to check your work, look how simple it is to check your work. 3 to the 2 times the 8 minus 9 is supposed to be equal to 3 to the 7. Well, what is 2 times 8? 3 to the 16 minus 9. The question is it equal? What's 16 minus 9?
7.
Is 3 to the 7 equals to 3 to the 7?
Yes.
Then that's the good answer. All right, let's try another one. We have two exponential functions set equal to each other. Do they have the same base? Matthias, do they have the same base? What is the base? Well, then, if they have the same bases, that must mean their exponents have to be equal. So I set their exponents equal to each other. And I solve this. I'm going to move the 2w over, the negative 2w, by adding 2w. That gives me 6w. I'm going to take the minus 1 and add 1 to both sides, equals to 6. W has to be 1. Told you this was going to be easy. Or would you rather graph a whole bunch more?
I think we would rather do this.
This is easier, right? Oh, then I get to this one.
Not so bad either.
Look at all those bases that I got. The only problem is I only want one base on the left. I don't want two bases on the left. I want one base on each side. So I have to do something else. You already had some skills. This is multiplying of two like bases. Isn't there a rule for that when they have exponents? When you multiply like bases, what do I do with the exponents?
You add them?
You add them. You keep the base, and we take the c minus 1, and I add it to 3c plus 2. Equal to the right side, 5 to the 7c plus 1. Oh, that's a plus 16. I didn't see it because I had it zoomed in or something. So now that Jonathan said that to rename these two bases with one base, we keep the base 5 and we add the exponents. That's what we do when we multiply like bases together. with exponents. We keep the base and we add the exponents. So I'm going to rewrite that as 5 to the c plus 3c is 4c's. The minus 1 plus 2 is a plus 1. Please double check my math.
Looks right so far.
I don't even know what's happening.
Well, when you snooze, you lose. Yeah, we went to the next. The homework is the last problem on that page that we haven't done, and the next 4 on the other side. Those are review graphing. And so now,
Our homework is only this one?
that one, turn it over,
Oh, and all these?
and the 4, yeah. What we just did, Adam, we moved on to solving exponential equations.
Sir, do you have freshmen?
Do I have freshmen?
Yes.
Well, sometimes some of them act like freshmen, but they're not.
Hey, sir.
Hey,
Yes.
how are you doing? It's good. Ow, that's so rough.
Sir, I have eczema.
Oh, well, yeah, but that's really rough eczema.
That's mean. It's like me saying if you had rough eczema.
I do.
Oh.
Like
That's
sandpaper, see?
bad.
How you doing?
Good, how are you?
Fabulous.
Do you remember my name?
Yes.
No, you don't. What is it? You don't, sir.
I can't say her last name.
What's my first name? Sir, it's-
Chrissa.
Wow. What's
Sir,
my
her
last name?
name's Jarvie.
I can never pronounce it.
Javeri.
Juveberry.
Javeri.
Jovery.
It doesn't matter. She did not know herself. Sir, what are you teaching?
We are solving exponential
Oh, I
equations.
totally
Is this
remember how to do
pre-calculus?
Yes.
Oh.
It's pre-cal, not calculus.
I'm taking
Calculus is
calculus.
limitations.
But pre-cal means pre-calculus.
I remember this, sir.
You do, right?
Yeah. I can
Yeah.
teach this whole thing.
So why are you coming looking for freshmen?
Oh, we're taking
yearbook.
pictures. Freshman.
Oh.
You wanna teach this entire thing?
Yes,
No,
sir.
I remember.
Matthias, he's volunteering to be a freshman.
Yeah, Matthias, you can be a freshman.
Class freshman?
No,
Your
these
class
are,
is gone.
Sir, this class
They're all
is
gone.
6 people.
no, but it's supposed to be 14.
It's a
Oh.
small class in general.
Oh.
My bio class has 8 people. We had 2 last.
All of my classes have been full.
It's the underclassmen, they're taking time off. Because their
Oh.
parents still care.
Upperclassmen.
So you're saying our parents don't care about
Well,
us?
no, they trust you to make your own decisions.
Well, my decision was to stay home.
You-
Not
you-
gonna lie.
And I see you're still here.
Yeah.
Responsible.
You know why? Because I wanted to see you today. I'm not going to school tomorrow.
Really?
No, I am.
Oh. Well, I'm glad to see you too. Glad you're back,
Okay,
healthy.
Kristen, go take pictures. I'm gonna see you.
All right, have fun with pictures.
No, sir, I'm saying.
Okay.
I like your class.
They're good kids.
I really want her to give it a try to teaching. Teaching is hard. It's not, it's not great.
She can do it. She can do it.
You can do it.
Help me out here now. If the bases are the
I
same,
don't
Add
remember
the
this,
exponents.
honestly.
if the bases are the same, the exponents have to be the same.
Yeah. And then you add them.
And we solve it, right?
Oh, sir, we did derivatives for this.
Ironically, it fell in the same point that we were doing graphing exponentials.
You're like du over u,
Yeah.
not ln u. I was very confused.
Yep, you got it. So what is C?
C is -5.
C is what?
-5.
-5?
Four to the other side, that gives you 3. C is equal
All
to
right, it's good
-15.
seeing you, ladies.
And divide on both sides, and you get -5.
Anybody else agree with his answer? Because you have seen him wrong this today.
I mean, apparently I was snoozing, so.
My brain has effectively just died off.
You were snoozing?
No, you said I was. You said I was.
That you were? Oh no! When you that's you snooze, you lose. Yeah.
Sir, I'm still
You-
suffering from ISIS, sir.
Oh,
Sir, do you do sophomores in the hallway always have like a speaker and you're playing like really loud music? for
-20 plus.
Let's see. -7C, -7C, -1. That gives me a -3C equals to 15. C is a -5.
Wait, what? Wait. That doesn't. Wait, -3 is equal to 5. That would give you a 5.
4 minus 7 is a -3.
-3C is equal to 15, correct?
Right.
But that wouldn't be a negative anymore.
Why not?
Because because
I'm dividing both sides by a negative 3.
Never mind, I'm dumb.
I got that on recording.
I'm dumb.
Okay, moving on here. Number 4.
It's funny.
This time, both sides have extra bases. So the whole deal is to still combine them to make, I don't want that picture, I want this picture. I want them both to have an 8 as a base. So this was going to be a little harder, guys, because I now have to take all of this and add it to all of this. So if you look at that carefully, that's a k squared, and there's no other k squares. This is a k, and it adds to 2k, so that makes it 3k. There's no constants over here, but there's a negative 9 here. So that's all 4 terms added together to make a quadratic. Equal to, this side is strictly 4k plus 11. Now that's what we do. I'm multiplying like bases. I keep the base and I add the exponents. But now I'm solving this equation with like bases being the same. That means the exponents are the same. So I have a k squared plus a 4k minus a 9 now equal to a,
Wait, isn't that a 3K on
it was supposed to be a
K squared?
3k, yeah. Glad you caught that. Equals to 4k plus 11. Now, this is called a quadratic equation. How do you solve quadratic equations?
You said equal to 0?
You got to move everything to one side and get a 0. So the k squared will stay here. This becomes a minus 4k minus 4k. 3 minus 4 is just a negative 1, I think. Minus 11, minus 11, minus a 20. All equal to that 0. How do we finish solving it?
Wait, where did you get the negative 20?
Negative 9 minus 11.
Is it? Oh, it is.
What method do we use to solve quadratics?
Oh, factors.
The F word? Oh, oh my gosh. Factoring, if it factors, right? If it factors, and I think it does, probably a k minus a 5 and a k plus a 4, because 5 times 4 was 20 and one of them had to be negative, and make the big one negative since this middle term's negative. Has to be 0,
Let me just.
which implies that k can be a 5 and k can also be a negative 4, would also work up in this equation here. 2 answers are possible when it's quadratic.
Do we have to know which answer it is?
It's both of them.
Oh, oopsie.
They both can work.
Oh.
No extraneous solutions?
Exponential functions don't have any extraneous solutions.
Oh, that's
But can I take see number 1 so I know what's happening?
Number 1 was the one for first graders.
Oh, great.
What number 1's explaining is if the bases are the same, you can effectively throw them out of the window and just solve 2x minus 9 is equal
That's
to
kind of violent.
It's
Oh,
kind
so
of
the-
violent.
the
Throw them
bases-
out the window.
The bases are, like, they don't really matter.
They won't really matter. They're the same base. Now, we could show it algebraically how they go away. We'll do that the next lesson when they're not the same. But in this case, just we'll just take our word for it.
Ow, though. 3 to the power of 7, really?
Actually, the next one's going to be kind of iffy too. Look at, are the bases the same?
Then you'll have to make one side base the same. But
How?
9 to the power of 2.
Wait, what's the answer to number, what is it, the answer?
What was the answer, number 1?
That's equals to,
What'd you get? Did you solve the equation?
I got 8.
Yeah, same.
Yeah, it was 8. Yeah. All right, this is where that there's not a common base, and so Jonathan's right. If you don't have one, can you turn it into one?
Yes.
The answer is not always going to be yes. It could be no. There's no way to do it. But he actually gave us the secret.
Wait, but what if there is no way to make a common base? You just ignore the problem?
No, it becomes a lot more work.
Yikes.
We'll get to that next time. But right now, I'm going to take your word. I'm going to keep 9 to the 4v minus 26 equals to 9 squared. That way, I'm able to just say the 9's go away, and I got 4v minus 26 equals to a 2. I just set those two exponents equal to each other.
Wait, so how do we get the 9 to the...
He knew his times tables that 9 squared is 81.
Oh.
See, he had to realize, okay, I have a 9 I'm kind of stuck with. Can this become a 9? And he said 9 squared. Kind of impressed that he thought that through, to be honest with you. I don't think the average person is going to think that I can do that. But Jonathan is not always the average person.
Unfortunately.
He's an alien, sir.
Here we
Yeah.
go again.
Well, you know, but he said
He's an android.
he said he's not even, he's like, did you say you were the dumbest one in your family?
Yep, I am.
I would hate to have dinner at your house.
Still an alien.
I would, huh? Sharpener, yeah.
I can't find it.
I did have one over there.
It's broken, look, it's right behind the shield. It's jank. I don't know what happened to it.
Oh, it broke?
I'll just use it for everyone.
Actually, I think it just fell off. It doesn't kill me for doing this.
Oh, it's not broke. You can use it.
You can still use it.
I think it's perfect for that.
All right, let's finish solving this. What is V?
Oh, it's a V. Oh, I thought it was a V. No, it's a Y.
Oh, a Y?
It is
What's Y? Yeah, you're right.
Y is equal to 7.
7? Okay.
Get there.
Nice job. Okay. All right. This time, if I'm going to use Jonathan's thought process,
Is it a negative 1? Or no?
you're so close.
Negative. Wait.
Negative what?
It's a negative something.
It is. Well, try something in your head. I'm glad he says negative. He must realize that this has to be some negative exponent over
Is
here.
it 4 negative?
No.
4?
It's
4 negative 4?
I don't know.
Anybody?
it's 3. Negative 3.
Oh.
Oh, he was so close.
It's 16 times itself again. 16 times 4 is 64, and you just have to make a negative, so it's 1 over 64.
So, yeah, you could have said like 4 times 4 is 16 times another 4. Negative 3.
3 negative 3. So I was like, that isn't. They're not the same exponent. Or-
No. He was. I think he was replying to it's a negative 3, not the negative 4. So now we have the same bases. So you got the negative 3 now is equal to a squared minus 4, which, by the way, is quadratic again. But because you don't have any a in there by itself, you don't have to set it all equal to 0 unless you want to.
It's a squared minus 1.
Well, normally we'd say ax squared plus bx plus c, but in this case I have a squared, but I don't have this term. So I don't really have to set it all equal to 0. I can just solve this for a squared. A squared must be equal to 1, I think.
What? I thought it was negative.
Oh, yeah. And then you square root both sides.
Well, yeah, you have to square root both sides, which is where you get a can be plus or minus 1. So you're right, Adam. It is negative 1, but it also is the 1.
Yeah, it's because they moved the 3 instead of the 4. But
Yeah.
So, you good to this one?
How are you in your notes?
Yeah.
You had this one done too? Okay, wrap that one up so you can go. Because the next two are kind of really hard. So you want to make it back in time to.
Oh, no. Yeah. Oh, God.
do we have to solve? No.
Now, let's use the same idea, guys. My smaller base is a 2. So is there a 2 to a power that's a 32? And if you don't know, do some multiplying. 2 times 2 times 2 times 2 times 2 times 2 times. Try them out and see what it could possibly be.
2, 4, 8, 16, 32.
2, 4, 8, 16, 32.
So it's 5?
Yes, it would be. So 2 is raised to the m minus 9. 32 I'm going to write as 2 to the 5. But this is where it gets tricky. All of 2 to the 5 is raised to the m plus 3. So now I have to ask another question that I do know you guys know the answer. How do you handle a base to a power to another power?
You multiply this number.
By multiplication. That's right.
Do you
So it's
distribute
5m
or
plus
do you?
Well, how do you multiply a 2 times an m plus 3?
I'm assuming you distribute.
And you'd be assuming correctly. So it's 2 to the m minus 9 has to be equal to 2 to the 5m
Plus 15.
5m plus 15.
plus the 15. That was the hardest part right there. Now that you've got that down to like bases set equal to each other, that means the exponents have to be equal. M minus 9 has to be equal to 5m plus 15. From there, just maybe your baby sister can do this problem now. I'm going to move 5m over, make it a negative 4m, but some of you didn't do that. Now I'm going to add 9 to both sides, making
Oh, it's 5.
a 14, I think. Am I right?
No, isn't it?
Or is it
No,
No,
because
plus
20
9 on both sides.
24
That would
then.
get
yeah, I put plus 9 on both.
24? So m must be what?
Negative 6.
A negative 6. So that was a pretty tricky problem because it was different. Obviously, it was different than the other ones. I kind of like how she does her stuff, how they start out kind of easy, then they get harder as you go. But they don't jump. Sometimes a textbook will go from like problem number 1 to problem number 12, and without even practicing in the middle, So I kind of like her materials. Okay, look at this on 8. I've got 2 terms on the left-hand side. Somehow, she must be thinking I still need a common base. And if that one has a 12 to something, can this one become a 12 to something?
How you raise it to the power of a negative 1?
Oh, true.
Will that do it?
That would flip the thing, wouldn't it?
Yeah, that was.
Well, yes, that would flip it. That's right. But write down what you just said. 12 to the negative 1 is the same thing as 1/12 raised to the 4x plus 3.
And then you can just multiply the.
And this is still a 12 raised to the x squared, right?
I still have another question. What if you raise 1 over 12 by negative 1?
That is what you're doing.
Oh, we did do that.
Oh, alright.
I think what you were thinking, could I take the 12 and raise it to a negative 1, make it 1 over 12? You could have, but then you'd have to mess up with this side too. So now I have a power to a power, which I do what?
Multiply.
So that turns into 12. What's 4x times a negative 1?
Negative 4x minus 3.
And then a 3 times, and was it minus 3? 12 to the x squared. 12 to the 2x plus 13. Okay, wow. A lot of work on this one. Like bases being multiplied together, I keep the base and do what with the exponents?
You add.
I add those.
So x squared minus 4
X squared minus 4x
minus 3.
minus 3 has to be equal to 12 to the 2x plus the 13. Okay. So now I have 2 exponential functions with the same base equal to each other. That means the exponents have to be equal. X squared minus 4x minus 3 has to be equal to 2x plus the 13. Again, this is a quadratic equation that I have x squares and a 4x in there, so I have to get everything on one side. I'd probably subtract 2x and subtract the 13. X squared. What's a negative 4x subtract 2x?
Minus 6x.
Okay. What's a negative 3 subtract 13?
Negative 16.
Equal to 0. Does it factor?
Maybe.
I'm still behind.
Me too. Because I'm thinking about those numbers.
We could just throw into the quadratic equation
how it works.
Or start thinking about what are the factors of 16. Obviously 1 and 16 doesn't work.
Negative 8 and 2?
Does a 2 and an 8 possibly work?
Negative 8 and 2.
A negative 8 and a positive 2.
Yep.
X minus 8, x plus 2. Yeah, I do see it gives me a negative 16. And I do see that if
That's a 16.
Yeah.
If it wasn't 11, that's why I was like,
Oh, sorry.
the magic.
So one of your answers would be 8, and the other answer would be a negative 2. And I am glad Jonathan asked about extraneous answers, like it happened before. Is it possible that one of these answers don't work? Not in this case, because the exponential functions, x can be anything. Nothing against the law.
I see. Oh, that's what it means.
Okay, so how many went to left? Whew.
Few doesn't.
Let's see. How about, I'll be happy if you wrap up these 4 before the bell rings.
That's the last page.
It is. The next work on this right now.
What numbers are
9, 10, 11, 12. So why don't we, I'll stop in, I'll bother you in a minute to make sure that we're all getting the, it starts out kind of tricky. Matthias, how you doing? I usually see you more alive.
Huh?
I usually see you more alive.
It's because Tyler's
You used to see me more alive?
More alive.
Oh, so our calculators
So
are?
Are you really that sad that Tyler's not here?
No, sorry, like, so you don't understand how, like, close I was to falling asleep today in like, my first week period. Like, I just been tired all day, because, like, my sleep schedule got so messed up. And, like, I just can't get, like, good sleep anymore.
Yeah.
So I just, like, need days off and do it.
You're dazing.
You know, I can't lie, this is a bit tricky.
I already don't like numbers.
First number already, right off the bat.
Don't be too worried. The other class, I didn't have anybody have it done after 2 minutes. They were like, okay, we're stuck already. They go, hey, you can't be stuck on the first one I give you on your own. They said, well, we are. What do you do? Fire us? I said, yeah, you're all fired.
You're like, detention. Don't give them ISS.
Yeah.
ISS.
It was going to get I just like turn it into referral.
You know, I have to be completely honest, I won't be able to finish in 2 minutes.
What?
There's something weird about those numbers.
So it wasn't just them?
Yeah, it wasn't just them. I even got out my calculator.
All right. Let's be a thought-provoking set of people. Obviously, I need to create the same base. Yes. Really? During this hard problem? Go ahead. Pass it. Did you fill out a past Gibran?
Yeah.
Was there another one left?
It's
No,
a
there's
blank
only
page.
one, sir.
Only one left, or you had the last one?
Huh?
You were the last one.
Yeah.
Well, come and get the other one. It's on my printer.
Hey, there is no way I can do that.
Well, yes, you can, Jonathan. Think about it. My printer.
Oh.
My printer has it. My printer.
Hey, my fault.
I printed some off, so go ahead, grab it. Fill out that top one and take it with you. So, what goes into 49? What base could you use? 7 what? 7 what?
Oh, common
7
bases.
squared.
Oh.
So then ask yourself, is it possible that 7s can go into 343?
Like that, okay. Makes a lot more common bases.
Yeah. These are all trying to make a common base out of magic, Hocus pocus, wave your hands and make something happen.
Thank you very much.
So how many 7s go into 343?
49.
Which is made up by 7 to the second power.
Yeah.
So it's 7 times 7 to the second power turns into what? 7 to what power?
7 to the third.
Yeah, exactly. You did it, Adam.
Do I get points?
Okay, Adam, points.
Hey.
Adam, points. Okay, so 7 to the third is all raised to the 2n minus 4. This one, okay, but I don't really want 1 over 7 squared. How can I fix it?
Um,
How do I flip it again?
but 7 over negative 1? Or 7? I can't get the words right.
All right, take off his points.
No!
Wait, wait.
Oh.
7 squared is good, but what makes it on the top instead of the bottom?
Negative 1.
No,
Oh, oopsie.
it's already a 7 squared.
Oh. Tee-hee.
Not a negative 1, but a negative 2.
Oh, oopsie.
Do you see that? 7 to the negative 2 would be 1 over 49. All right, Adam, I'll put the point back. N plus 4. All right, so now this becomes 7 to the, distribute that 3 to the 2n minus 4, 6n minus 12, thank you. Hurt somebody. 7 negative 2n
No, oopsie,
minus 8.
Yeah.
Okay. So now that you got the same bases set equal to each other, we can take the exponents, set them equal to each other. Negative 2n minus 8, and hopefully it solves. 8n equals to 4.
Oh, it is positive 4. Yeah, yeah, yeah. So it's just
N is
half?
1/2. Yep, it's possible. N could be just a half.
That's annoying.
It's a little different than the other answers, right?
Okay, now that I realize that, I think these questions are
I think they're still idiots.
So now when I looked at 10, I thought I could try to turn them all into 8s. 8 to a power, 8 to a power, and somebody pointed me to the right direction and said, no, 8 to nothing is 128. They tried all the numbers.
Oh, yeah, yeah, because 8 times 8 to the third is 514.
It went too far.
And 8 squared is just 64.
So they said you need to pick a smaller number than 8. Maybe a number that can go, okay, 4 could be 1 possibly, except 4 to what power is 8? 4 to nothing is 8.
So you would have to reduce the bases to 2.
Well, actually, there is a number. I mean, you can figure it out, but it's not going to be a whole number.
Oh,
Say it again?
So
Oh,
you have
use
to
a
reduce
base
the
of a
base to
2?
Yeah.
Yeah, who said you can't even use a base smaller than a 4? You could use a base of a 2. How does 2 become an 8?
To the
3.
3.
To the 3, that's right.
The power of 7 is 1.
And then that gives you the 2 minus v over there. What'd you say, 2 to what?
Power of 7 and,
Oh, okay. See how that works out?
and then it works out.
Yeah, it worked out pretty good, right? So now you're home free from there. Let's look at number 11. Ooh. I said ooh too, but because I'm looking at, I think we got to use a smaller power than 9. Smaller base than 9.
Let's try 3.
A 3?
Yeah, maybe, yeah, 3.
All right, so
3 squared is
3 squared is 9 raised to the negative p. And is there a 3 to a power that's 243?
3 to the power of 5.
Are you sure?
Absolute.
Oh,
Yeah, he's right.
3 to the power of 5 is 243 raised to the 2p plus 6. Okay. So if you're right, and I don't have my times tables memorized to know that 3 to the 5th is it.
Calculator.
Oh, calculator. So there's your power to a power. You're going to multiply. Here's your power to a power. You're going to distribute that one as well. Okay, let's go to 12. And you want to make a bet that I'm going to want to use a negative number for both bases? Because I know 4 goes into 64, doesn't it? 4 to the third? 4 times 4 is 16. 16 times 4 is 64.
Equals 3, yep.
But-
Negative 3.
Well, I'm going to make them negative, though, because it's a fraction. That's 4 to the negative 1.
Oh, it's 224.
Wait, couldn't you just use? Wait, why would you use both? You could just use 3. You could just use 3.
To
1/4.
3.
That'll give you 164. Yeah.
Where are we at? I know, we're going to. 4 to the negative 3. We are. Didn't we already agree on that?
No, I'm saying you don't have to change the second base. You can just use a normal. 3.
Oh, you're saying I could just left them as a fraction?
So you don't have to mess with the top exponent and.
Oh, I never thought of that.
That one's actually you could actually get.
Oh, I see what you're saying. You're saying I could have left this as 1/4, and then I could have left this as 1/4 to the negative 3, like that. Yeah, you could have kept it like that.
It simplifies a lot more things.
Yeah. All right, you guys could wrap those up, and the homework is those 5 graphs.
Alright.
All right. So everybody say goodbye to Tyler.
Bye.
What? Tyler.
Because he's not in here. Well, who else? You got Etsy?
Yaretsi,
Who else?
Emil, Maya.
Emil, Maya. Who else? Valerie. Who else? Hema.
Emma.
Who else? Who? Alexa. And oh, what the heck? Who else is not here? Who'll never be back?
Julian.
Julian. Bye, Julian. Should be like homework, but I'm not giving.